Georgia, and finishing with Mariana Barboza from the University of California, Davis. I'd like to pass the microphone and video off to Michael Tiemeyeron. Thank you.
I'm sorry, I guess I was muted. My name is Michael Tiemeyeron. I'm co-director of the Complex Carbohydrate Research Center at the University of Georgia. The speakers for our session today will be presenting some really cutting-edge analytics, informatics, and integrated omics techniques, and I hope you'll enjoy these sessions. I'll be giving the first talk today. The title of my talk is GlyGen, Computational Resources for Glycoscience. And this is a project that involves a large number of people, including a large group at George Washington University, as well as a group at Georgetown and the University of Georgia, and several international collaborators. The rationale for this project is that we know quite a bit about the basic building blocks of life. They can roughly be grouped into 4 categories: the nucleic acids, the proteins, and the lipids, as well as glycans. And for 3 of these major building blocks of life, there are very well curated, robust data sets that are well funded and subject to ongoing curation and activity. So the question is, what about glycans? What about glycans? Where are the glycan databases? And what has hindered their development over the years? In part, this is a direct result of the complexity of these molecules in comparison to proteins and nucleic acids, which are linear polymers. Glycans are branched, can be linked together in many different ways. And that creates problems for thinking about how to describe glycans in a way that a machine can read it and it can be dealt with in an informatic fashion. Well, over the last 30 years or so, many very hardworking, diligent, intelligent people have worked together to try and come up with ways to describe glycans in a machine-readable fashion. And this has opened the door to thinking about building databases. And there are several efforts around the world to do so, and we work with all of these efforts to try and develop this resource that we call GlyGen. So we seek really to build on the shoulders of those that have come before to provide a stable, broadly useful resource that can bring together all sorts of data. And I'll tell you a bit about what sorts of data we bring together. Just a little bit of brief background. GlyGen is supported by the NIH Common Fund. That funding was initiated in 2017, so we're just ending the 3rd year of our first 5 years of funding. And importantly, I want to point out that this resource began with a year of planning where we engaged stakeholders in the glycoscience community and beyond and tried to get input from users about what they would like to see in a sort of bioinformatic resource that describes glycoscience. We continue to reach out for this kind of input, and we hope that we can get some from you, or if you have ideas that you'll please pass them along. And it's also important to point out that our resource is only as good as the data that we can get from the community. So we're always looking to collaborate to make this resource more valuable. So at the center of GlyGen is 3-fold sets of data: protein data, glycan data, and then glycans on protein or glycoprotein data. These 3 components of GlyGen build off of all sorts of other data that we access and bring in and integrate, both within the protein world. We pull data, and we actually also provide links for these other resources to get data from us. So it's an interactive process of driving the build of this database. For protein data, for glycan data, we pull and interact with many different data sources. And for mapping glycans onto glycoproteins, we interact with active curators and other sources of data. So a major role of GlyGen is to harmonize this data, to bring it all together in a way that we can integrate it. So we use uniprot accession numbers to describe proteins as our way to harmonize the description of proteins and access protein information. For glycans, having accession numbers is a big advantage, and we work with collaborators around the world, including Kyoko Kinoshita in Japan, to use glytoucan numbers as our accession source to explicitly describe glycan structures. And if you're interested in how that works, I encourage you to go to glytoucan.org, where you can actually describe your glycan and get an accession number. So how do you access the data in GlyGen? So there's two ways I'm going to tell you about, two general ways. One is that you can go to the GlyGen data portal, and you can see all the data that we have in table forms, all the different types of data that is accessible through GlyGen. And you can see the APIs that we've developed to interrogate this data, and you're free to use this in any way you'd like. You can ask your own questions of the data in any way that you'd like to do that. All the data is freely available. We just require that you acknowledge GlyGen and cite us in your publications. We operate under the terms of CC by 4.0. So if you're really good at working on large data sets with your own query bases, please feel free to go and use the data. Today, I'm going to spend the rest of my time talking about the portal, which is a little bit more accessible to everybody. To talk about how you access the data, give you a little bit of a demo of the sorts of things that you can do on our portal. So this is the homepage for glygen.org. This is the homepage portal. And you can see again the organization by glycan, protein, and glycoprotein is to enter into the data set and look at what we have. So a couple features. First, I want to point out that we have a very rapid versioning cycle. We put out a new version every 3 months, which allows us to make sure that we're responding to the needs of the community in a timely fashion. And your feedback is absolutely essential for us to improve this resource. So we really encourage you, if you try this, to let us know how it works for you or where you might find shortcomings. So there are several ways now from the portal to access the data. Up across the top here, you'll see this Try Me tag, and let's just explore that a second. Try Me is designed to demonstrate to you what GlyGen can do. So these are very explicit questions that you can click on and see the answers to, sort of prepackaged demonstrations of the sorts of things you can get from GlyGen. Also, another way to access the data is through a quick search, and these quick searches are use case questions that were designed by the community in our planning process that would be useful questions that users might like to ask. For instance, which proteins have a particular glycan and where is that glycan attached? So if these questions are what you need, you can feel free to explore these. I'm going to take a little bit deeper look at these other mechanisms of exploring GlyGen, and these are glycan searches, protein searches, and glycoprotein searches. So let's look at a glycan search first. So for all of the searches, you'll notice that there are tutorials available to help you see how to use GlyGen. I encourage you to take a look at those. There's also feedback on every page, and so if you click the feedback, you'll also have an opportunity here to let us know what's working or not working on this particular page. So it'll help us fix particular specific problems that you might encounter. So let's start by just looking at a simple search in the glycan search domain. And so if you knew your glytoucan accession number, which examples are provided here, you could enter that glytoucan accession number and click on the search. So that raises the question, what if you don't know what your glytoucan accession number is? Well, you can access those at the glytoucan website, or you can also access them by doing these advanced search or composition searches up here, which I don't really have time to talk about today, but you can enter characteristics of your glycan, and it will return options, including the glytoucan accession numbers. But just to get a feel for what a glycan search can do, if we enter in one of these glytoucan accessions, it takes you to a glycan list page, and since we put in a very specific accession, we get back this one well-described, completely described glycan. And so now if you click on the glytoucan accession number, it'll take you to a glycan detail page where all this sort of information is available about this particular glycan. And let's look at this particular aspect of the information, and it can shows that glycan structure that you entered has particular structural motifs that are shared by other glycans, and one can explore what those motifs are by clicking on these. Also, it lets you know what glycoproteins have been found to carry that glycan. And the evidence that that is in fact the case is provided by these badges that can take you to the original data source so you can evaluate that yourself. So let's click on one of these proteins that carries this glycan, and now you go to a protein detail page, which provides all sorts of different types of information related to that protein. And I'm not going to show those detail pages here. Instead, I'm going to take us back to the home page and show you a glycoprotein search. So by clicking on the glycoprotein search, you can again do a simple search. We're going to look at an advanced search here for a glycoprotein. I'm going to enter a couple facts about a protein, Homo sapiens version of hepatocyte growth factor. I want to know about its end-link glycosylation. You hit search and it takes me to a list page where, in fact, here's that protein I'm interested in, Homo sapiens HGF. I click on the uniprotic session. It takes us to a glycoprotein detail page where, again, all this sorts of information is available. And we're going to look at glycosylation first for this protein. So it takes us to a table where we can now look site by site at the glycosylation sites in this protein. And by clicking on a particular site, you can see the site view, that is, what's the sequence context surrounding that end-link glycosylation site. And scrolling down, and then you can see a table of all the glycans that have been described on that particular glycan. Another way to look at the overall sequence distribution of glycans on this protein is to use the view, which provides the sequence stretched out in a linear fashion, and you can click or hover over these glycosylation sites and also access the diversity of glycosylation at each of those sites. And in an overview fashion, you can look by toggling these selection boxes. You can look at where the different mutations in the protein have been described, where the end-link consensus sites are, where O-link consensus sites are, and even you start to overlap where mutations might exist in particular glycosylation sequence or features. So I showed you these sorts of glycan search and glycoprotein search. There's also, from the home page, if you know what you're interested in or a term that you're interested in, you can enter that into the global search, which searches across all the data domains and provides sort of an intuitive interface where you can see what sorts of results come from the search. So, for instance, you could go to glycoproteins, and we would be right back to where we were in the beginning, where we explored hepatocyte growth factor from a results page. So I tried to take you around in a relatively quick way some of the features of GlyGen, and hope that you'll go back and spend your own time at your own leisure and investigate what GlyGen can do for you and give us some feedback. And just to summarize, I just want to emphasize that this resource was conceived and designed to try and cross boundaries, disciplinary boundaries, to build access to glycomic and glycoscience data. And as the diversity of our data increases, obviously this resource will become more and more valuable. But always in the end, the value of this resource is going to be directly proportional to how we can work with the community to integrate data in the glycoscience domain. And I will just finish by thanking everybody that's contributed to this resource over the last 3 years, and will continue to build this resource into the future. And I'd be happy to answer any questions.
Thank you, Michael, for walking us through this wonderful resource that is now available to us. I do have a question for you, and actually several. The question that I have is, if an interested user have a big data set that would like to be uploaded into the platform, what would be the best way to do it?
Thank you. That's a very useful question. So the easiest way right now is to contact us directly through the GlyGen website. Just drop us a note in any of the feedback boxes, or send us an email directly, or send me an email directly, or any of the contacts on the website. And we'll work with you to make sure that the data gets into a format that it easily gets folded into our data sets. We are working on a direct deposition portal within GlyGen, but it's frequently it's just much easier to do this one-on-one, face-to-face, or chat by chat to help massage the data into the format that makes it integrate most easily.
Excellent. We are waiting for some questions.
Mariana, there's one in the chat box.
Thank you. All right. We do have a question, and it is it possible to study the cluster of proteins working as operons using GlyGen database to understand metabolite modifications?
It's possible to ask questions related to what enzymes are required to build particular glycans or degrade particular glycans. So it's possible to understand aspects of the organization of glycan biosynthesis. We're working very hard to build those sort of pathway simulators up in a way that they can provide additional linkages to deeper sorts of data. In terms of operons, we're not currently capturing microbial glycan or glycan biosynthetic pathways. That's a goal for the future. But it is possible to understand what mammalian enzymes would be required to achieve certain biosynthetic goals.
Great. And we do have another question. It is from Nusra. And the question is data analysis similar to using NCBI or EBI?
Yes, very similar. In fact, we work closely with NCBI to try and link where we can link to those resources. And so we have some parallel efforts to enhance NCBI's description of glycans, and we use PubChem and other resources to help enrich our data sets as well.
Okay. And I think that those are the questions that we have today.
Okay, I guess we should move on to the next speaker. The next speaker is Richard Drake. And Richard, you can go ahead and share and introduce yourself.